Welcome to the Lutzer 360 Degree video blog. Today we're talking about demand-oriented cooling. I have Daniel Haag from the IGTE at the University of Stuttgart as our guest. Great to have you here, Daniel. Perhaps you could tell us about yourself.
Ja, vielen Dank, Michael.
Thank you, Michael.
Ja,
My name is Daniel Haag. I'm a doctoral student at the Institute of Building Energy, Thermal Engineering and Energy Storage at the University of Stuttgart. We focus on current topics related to energy efficiency and resource conservation, and we are particularly interested in the innovations that are emerging in the market, especially in my specific research area of electronic cooling and cabinet cooling.
von Schaltschränken.
And that brings us to our topic. As a researcher in this field, what's important to you when it comes to rethinking demand-oriented cooling? CO2 reduction is currently a highly discussed topic in politics and society. I assume this topic also plays a significant role in your research.
Absolut.
Absolutely, yes. Demand-oriented is actually the right buzzword. To provide some context, let's think about this. Why do we cool cabinets in the first place? On the one hand, there is power dissipation in the cabinet, and on the other hand, the electronic components have a certain temperature that should not be exceeded. These 2 points must be considered together.
Zusammenbringen, ja. Und
Another issue is resource conservation. Demand-oriented cabinet cooling is about using only the electricity needed to keep the cabinet cool. It's important to note that thermodynamics sets certain limits.
gewisse Grenzen, ja.
This means that above a certain temperature inside the cabinet, active cooling is required. Based on the two main laws of thermodynamics, the cabinet cannot have lower temperatures than the ambient temperature. In this case, heat is actively removed using a cooling device, but this comes at an energy cost. Therefore, when it comes to demand-oriented cooling, the focus should always be on implementing all other measures that can improve the cabinet climate. This includes aspects such as component layout optimization or the use of a duct-free wiring system. By implementing these measures, there are energy benefits that come for free. Another important point is that, from an energy perspective, moving air is much more efficient than generating cold air. This is where your air blower fan comes in handy. It helps create circulation around the airstream cabinet frame, mixing and homogenizing the air layers inside the cabinet, which already significantly reduces the average temperatures.
Senken.
Ja, perfekt. Ich meine, wir sind schon relativ tief in die Materie eingestiegen.
Perfect. We've already delved deep into the subject.
Überhaupt hin, dass ich meinen Schaltschrank richtig ausgelegt habe.
Actually, the topic starts with the planning of a cabinet.
Schrankischen Gedanken.
So I need to consider in advance what the right climate technology is and how I can achieve the perfect climate inside the cabinet.
Das perfekte Klima in dem Schaltschrank, ja.
Ja, absolut. Und vielleicht sollten
Yes, absolutely. And maybe we should first define how CO2 is generated inside the cabinet.
natürlich mal
Firstly, you have the actual operating energy of the cabinet, which is the energy it requires to function.
einen Schaltschrank.
And then there's the operating energy required for the cooling devices, for the fans. What is also a concern nowadays is the general CO2 footprint, even before the cabinet starts operating.
Heutigen Zeit ist generell der
Compressor refrigeration cooling devices, similar to household refrigerators, are very energy intensive to produce.
vergleichbar zu
They also have another disadvantage, the refrigerants they contain.
noch ein weiteres.
These refrigerants have a very high global warming potential, several times higher than CO2, which is why it's important to avoid these refrigerants.
Eben vermeidet. Ja, und dann
Finally, another point is maintenance and, if necessary, component replacement due to thermal failures.
an Komponentenaustausch, also
These factors also need to be considered in the CO2 balance.
was man dann da in den Schaltschrank reinsteckt, ja.
Also viel,
So a lot of embodied energy.
Genau. Und
Exactly. In our research, we try to first assess and quantify these factors to compare different concepts.
diese Konzepte vergleichen zu können.
okay. Also was wäre denn eigentlich
What can be concluded from that?
oder kann man eigentlich
Can we say that active energy is absolutely necessary?
natürlich diese Betriebssicherheit
After all, it's already needed to ensure operational safety. But how can we optimize a cabinet in terms of avoiding dead zones and preventing hotspots?
Hotspots vermeiden? So, da haben wir ja auch schon die eine
Auf jeden Fall, ja,
Sache
das ist ein
gemacht.
wichtiger Punkt, ja.
Correct. This is where the University of Stuttgart and Lutzer come together.
Firma Lütze, ja.
We support the theoretical assessment.
Unterstützen, ja.
In the academic context, we have entirely different possibilities. For example, we can perform a flow simulation of a cabinet. Let me briefly outline that here.
Zuhörerinnen und Zuhörer.
We can see a combination of cabinets. There are 3 cabinets numbered 1 to 3. In the middle cabinet, number 2, there is a cooling device. The streamlines show us where there is airflow, indicating movement inside the cabinet. Immediately, we can see that cabinets 1 and 3 have a problem. They have poor airflow. This means that if we were to actively cool them, it would require a significant amount of cooling energy. But that's exactly what we want to avoid. Through calculations, we can easily show that there is an optimization potential here. By using the circulating airflow generated by the air blower fan that we mentioned earlier, we can improve the climate directly in these areas without the need for much additional energy.
Also das würde bedeuten,
Okay, understood. So by using an air blower, we could easily thermally optimize cabinets 1 and 3.
aufgerissen werden.
That would open up the airflow layers, and with limited cooling energy, we could achieve a good climate in all 3 cabinets.
Das Klima in den Schaltschrank.
Exactly. Additionally, it should be noted that each cabinet or cabinet combination needs to be considered individually. In the worst case, you still have the option to activate the cooling device for cabinet number 2 as a backup. However, the ideal scenario is to run this cooling device as infrequently as possible, only when it's truly needed, such as during hot summer months. Yes, perfect. We're slowly approaching the end of the first 360-degree video blog. It was definitely very interesting. By the way, there will soon be some innovations in the area of air temp, temperature calculation and air blower fans. We don't want to reveal too much yet. Thank you for watching, and thank you as well for joining us and providing these fascinating insights. Thank you for the invitation. See you in the next Lutzer 360-degree video blog.
Den nächsten Block.